Well, good morning, everyone. So, in the last session, we have discussed about the PySpark, right? Am I audible? Hello?
Yes, Dev, you're audible.
Yes,
Okay.
Devnath.
Thank you. Thank you. In the last session, we have discussed about the what is Spark, what is PySpark, what is the use of PySpark. Let me open those things. Whatever the notes I am going to give you, right, that is the perfect one. No need to go for the thousands of website and spend time. Okay, don't waste your time because the perfect note I am going to give you, that is enough to crack the interview. That is enough to survive into the industry also. Okay, because so many example I am going to brings in the practical scenario. Got it? So in the last session, we have discussed about what is Spark. Spark basically a analytical processing engine, right? It will use to process the huge volume of data, the first thing. And the data is different types. That means the types means structured kind of data, unstructured data, semi-structured data. Okay. Then in what way it will going to process your data? It will process the data in a parallel style. Processing the data in a distributed manner and processing the data in a parallel manner is totally different. Okay, but people feel there are so many tutor and the trainers are there. They are saying that both are same, but both are not same in reality. Okay, I will explain you in a minute. Just give me some time. You will come to understand why I'm saying that parallel style processing and distributed style of processing both are different. Okay, then unified processing engine through multiple language support. It will support multiple language. That means the Spark, especially it is an engine only. But Spark can be processed either by using the R language or Python language or Scala language or Java language. But Spark is especially designed on top of JVM, Java. And and it will support the native language Java and Scala. And more preferably, people will, in when the Spark has come into the market, people are preferred to go for the Scala instead of Java. And after that, what happened? The people are these days preferring to go with the Python because Python is such a type of language that will contain so many library for each and everything. No need to rewrite the uh, module again and again. Just import the required module and utilize it. If you need to perform some calculation, import the math module, perform the calculation or perform the complex calculation because math module itself contain the tangent, then it will contain power, square root, then you can perform the mean deviation, standard deviation. Okay, so such complex kind of calculation you can perform through the module also, just importing the module, that's all, which is not at all available in Scala, which is makes SSL Python as compared to R, Python, Scala, and Java. Got it? And that's the reason what happened. PySpark is more in demand as compared to Python and Scala. Okay, Python, Spark, Python, Spark, yes, PySpark. So you will contain like Scala plus Spark. It is simply we are calling it Spark. Okay. Then R plus Spark. It is Spark R. Okay. Then Java. Few of the industry also using the Java with Spark. Okay. It is also Spark Java. This is why we are talking about these things. Okay. Suppose. So who has designed this particular language? This language has been designed in AMP lab, Berkeley, by Matai Jaharia. Matai Jaharia is the person who has invented this particular language to deal with the huge volume of data or variety of data and to process the data in a parallel manner, not in a distributed, both parallel in distributed as well as parallel style. Okay, to process the data, to process the data in distributed as well as parallel manner. Because in earlier Hadoop session, I have told you either Hadoop can able to process your data in a distributed manner or parallel manner, but not in the both way. But we require in the both way. Okay, where Spark is come into picture. Okay, fine. So later Spark project has been donated to the Apache Software Foundation. Okay, Apache Software Foundation is a open source organization that will whatever the project it will going to start, that will makes available in its website. Because whenever we are going to deal with that Hadoop, right, we have already Hadoop, Hive, so many softwares are there. We have downloaded from the Apache Software Foundation, and we have utilized in our Ubuntu. In Ubuntu also you can able to see. Got it? And Spark support different language to process huge volume data. And they are Scala, Python, or Java. And more in demand. Simply Spark and PySpark. PySpark means Spark with Python combination, and Spark means Spark with Scala's combination are in demand. Okay. These days, most of the organization are using PySpark as compared to Spark, since Python supports a huge Python has a huge volume of library. Okay, library means models here. Models. Got it. That's all. Okay. This is enough for your introduction. Okay. What is PySpark? PySpark is simply a Python API. That means we have written a Python API, and that Python API used to talk with the Spark engine to process the data. That's all. That means it is a library which is written in Python language to run the Spark engine. What is the need of running the Spark engine? In order to process huge volume and variety of data in a distributed as well as parallel manner. PySpark is used to process the huge volume of data in cluster environment with a Spark engine in a parallel style of processing. So PySpark has many features, and they are faster processing of data, then real-time computation with low latency. You know, Python is a interpreted language. Since it is a interpreted language means it will be going to read or execute the line by line code. Got it? Python is a interpreted language, and because of the same, Python codes are executed line by line. But whenever we are going to speak with Spark, right? Spark is a processing engine, so it will become faster. So it will provide you the faster processing of the data. Then real-time computation with low latency. Low latency means, what do you know low latency? Low latency means low latency means, in a sense, it will take hardly less time to fetch and process the data. Okay. Then multiple language support like Scala, Python, or Java. Powerful catching and disk persistent mechanism. We'll come to know in there are particular discussion is there with respect to the caching and disk persistent level mechanism that we come to know later. Okay, there will be some doubt at this point of time. Don't worry, but understand this point. Just keep in your mind. I will explain it in detail. Support of rich set of Python libraries and APIs. This is about the what is PySpark. Fine. Then what is the use of PySpark? It is used to process the data in a distributed and parallel manner in order to perform the analytical processing of the data stored across various nodes across the cluster. Then it will integrate with the different open source tool and framework. Next, it is used to perform data science. It is highly used for the data science, analytical processing, as well as data engineering. This is enough for you for the use. Okay, fine. Now we are going to another one. So many theory are there. Unnecessary theory are not going to. Whatever require, whatever interview point of view, whatever really require for a developer, right? Those things I'm going to elaborate more and more. Okay, let's understand what are the key features of PySpark. Okay, one point. This point I will discuss later. How PySpark PySpark process the data in a distributed as well as parallel style. This is one of the interview question. I will discuss in detail. Don't worry, and I will give the notes also for the same. Okay, but before that, I need to let me finish this one. Then, whenever the architecture will come, right, that point of time I will discuss this particular question. Okay, with answer, so that you can no need to worry about it. Okay, this is very important. Most of the peoples are failed to answer this question because both are saying that both are same. Most of the people. Okay, but I will distinguish what is the distributed manner of processing, what is parallel manner of processing. Okay, okay. What are the key features of PySpark? Okay, what are the key features? First, PySpark has so many features, and they are the first one. The first one, it support Python API. So many Python API. The second one is distributed computing. Distributed computing. The third one is fault tolerant. Fault tolerant. Because all these features are so much important because they will ask you in the interview room, what do you know fault tolerant? Okay. They will ask you what is fault tolerant, what is distributed computing, okay, what is lazy evaluation, what is lazy evaluation. Okay, lazy evaluation, integration with Python ecosystem, Python ecosystem. Then interactive data analysis. The seventh point. The seventh point is machine learning. Machine learning. It is used for machine learning. streaming, data processing. Okay, then SQL support. These are the important features of PySpark. So, what do you know Python API? PySpark, PySpark provides a Python API to interact with the Spark engine. Spark engine and engine, which will allow developers or allow us to leverage um, with the processing of data in a distributed and parallel manner by using the Spark computing system. What do you know this? PySpark provides the Python API so that you can able to interact with the Spark engine. And because of the same what happened, it will allow us to leverage the different PySpark. It will leverage us to process the data in a distributed and parallel manner. Process the huge variety of data in a distributed and parallel manner. PySpark provides a Python API that will allow us to interact with the Spark engine so that what happens, we can leverage the processing of the huge volume and variety of data in a distributed and parallel manner by using Spark computing, by using the Spark computing system. Okay, this is the first feature. The second feature, distributed computing. What do you mean by distributed computing? Let me explain you. Okay, let me take the help of a diagram. Try to understand this one. This is my, let's say, HDFS. Maybe reduce. And let me okay. Different nodes are there. Let's say this is a master node. Master node located in, let's say, California. Let's say data node, data node 1. Let's say it is in Singapore. Data node 2. This is in located in India. And data node 3. Let's say it is located in, let's say, and again in India. Got it? So What is distributed computing? Our data is, try to understand here, it is very, very important. Okay. So let me. Okay. Whenever you are going to get a file, okay, let's say the file name is a.txt. Okay. It's of 200 MB. Whenever the 200, and at this point of time, our replication is 3 times, block size is, let's say, 128 MB. Then how many blocks are there? How many blocks it will generate? 200 MB divided by,
2 blocks.
correct, 2 blocks. 128 MB. It will generate block B1, block B2. B1 contain 128 MB of data full. One 28 MB full data. It will contain remaining. Remaining how much? It will 72. Okay, 72 MB. Now, since the replication factor is 3 times, B1 will contain 3 copy. B2 also contain 3 copy. B1 3 copy will be like this. Let's say, okay. B1 copy will become B1, B1, C1, B1, C2, B1, C3. Got it? Likewise, B2, B2, C1, B2, C2, B2, C3. It will also contain 3 copy. Now, these 3 copy will be, stored across B1, C1 here, B2, C2 here, B3, C3 here. Okay. Let's say B2, C1 here, B2, C2 here, B3, C3 here. Got it? Now, what happened? Suppose, okay, whenever the processing will be in a, whenever your map reduce will process, okay, whenever map reduce will start the processing, either using the map reduce is a default processing engine that will comes whenever you are going to install the Hadoop. It is already, I already explained you earlier also. Every node, the node wherever you are going to install the Hadoop, by default it will comes with 2 core components. One is HDFS, another one is MapReduce. Got it? One is HDFS, one is MapReduce. It won't come with only one component. Okay, so, and it is the cluster environment. Which cluster environment? Hadoop cluster environment. Got it? So what happened? The MapReduce is the default processing engine. Before coming to Spark, Okay, let's understand how distributed computing will be performed here. And we can achieve either distributed, not parallel, either parallel, not distributed. Got it? So let's suppose my data is segregated across different nodes B1, C1, B1, C2, B1, C3, then B2, C1, B2, C2, B2, C3. Got it? In different nodes. Now, whenever a job will be started, whenever a job will be going to process, this file is file request is being sent by the client to store into the hardware environment. Then this file will be divided by the name node and distributed across different nodes and store. It will split the particular file into number of blocks and then it will replicate it number of times whatever the replication factor has been defined in the core-site.xml, and that number of times it is going to replicate and store across different node. Got it? Now what happened? Whenever the memory processing will be happen, it will what happen? It will going to read from this particular HDFS. Okay, the MR will be read from this HDFS. Suppose I have stored some file here. I have stored some file here. Then what happen? My machine will be, this machine will be, I need to read the data from my machine, my D drive or E drive, or should I going to read the data that is stored in any other machine? Not at all possible, right? Got it? Since likewise what happened? Whenever you are going to read the data, it will read the data from the its respective HDFS file system. Got it? Data node 2 will be read the data from data node 2 HDFS file system. Data node 3 will going to read the data from the data HDFS file system from its machine. Got it? And each of this machine, they are individually responsible to pass the information to this name node. Name node is nothing but your master node. Got it? Master node is nothing but your name node. Name node is nothing but your master node. They are going to individually pass the information. They will tell that I have completed this particular file. I have processed the file, and this is the output. Got it? So what happened in distributed environment? Try to understand this point. Whenever you are going to process the data, okay, in a distributed environment, first of all, it will process the data from the data node 1. Once it is finished, it will pass the information. Then it will, this input, the processing of this input will become the output to the another machine. Since I have taken here 3 nodes only, it is not only a single file in real time, it will be multiple file. Got it? A multiple file. So what happened? At this point of time, one more file is there, let's say. For your clarity, I am telling you. B.log file. And B.log file is, let's say, 300 MB. Or simply, let's say it is 128 MB. Perfectly. Okay. So 128 MB, I have stored in 3 machines. One more machine is there, let's say. One more machine is there. Got it? One more machine is there. I have stored across here. So what happened? As long as I am concentrated, I am going to process my data from A.txt. B.txt will be not going to process from this machine. It will process from another machine. Means I have stored the data in different nodes. Okay. So what happened? A.txt file is different. B.log file is different. Got it? Because this machine are only process one particular file at a time. Okay, one particular block at a time. They are not designed to process multiple blocks. This is either that means at the time of designing, in the real time, what happened? Either they will process this file or they will process this file. This file data will segregate into 3 different machines, and this file data will be processed in another 3 machines. Got it? The moment we are processing the data a.txt file, it's not at all going to touch your this file data. So what happened? To perform the distributed environment, the HDFS name node, it will make active to this one, and this will also process here, that is in another node. So this node is processing, this node is processing. Now a.txt file, it will contain the b1.c1 copy. Okay, b1.c1 copy. Once the b1.c1 copy will be processed, then we will start the b1 and c2 copy wherever it is stored. It is not, it does not guarantee that same machine will, even though it is contain the b1 and every machine does not contain, it does not guarantee that, sorry, one key rule is there. HD in the name data node contain only one copy or one replica at a time. B1 C1 is here, B2 C2 is B1 C2 is here, B1 C3 is here. Got it? Once it is done its processing, the next copy, this will come to the input. One second. Let me clarify because it's become a mess now. One second. Give me a moment. You need to understand this one. Okay. You tell me now. You need to talk with me. B1 C1 I have stored in which machine? Data node 1. B1 C2 I have stored in which machine? Data node 2. B1 C3 stored in which machine? Data node 3. So this data node 2, B1 C2, B1 C2 is a dependent file on which one? B1 C1 copy. Got it? Are you getting my point?
Right.
Are you getting my point or not getting my point?
Yes,
It does
Dev.
not get, here I am taking only 3 nodes. I am not taking only 4 nodes. But in real time, what happened? Same copy won't store in the multiple file. It does not guarantee that here I have stored B1 C1, here also B2 C1. It does not like that. It does not guarantee that your data will be stored in the same suppose B1 C1 and B2 C1. Either we need to process it to a copy, either B1 C1 plus B2 C1 is the complete text file, 200 MB of data. In our case, we have stored both B1 C1, B2 C1. Both block 1 copy we have stored in the data node 1, data node 2, data node 3. If one node is processing, it will finish the job. But in real time, what happened? I have stored the B1 C1 in data node 1, but B2 C1 must be a part of another one. Okay, because each and every copy will be different. What happened? Why it is different? I need to take some one more note so that you can understand what actually happened. Let's say B1 C1 I have stored here. B1 C1, let's say B1 C1 I have stored here. B1 C2 I have stored here. B1 C3 I have stored here. Now B2 C1 I have stored here. B2 C2 I have stored here. B2 C3 stored here. Then what happened in a distributed computing? Once the B1 C1 copy will be finished, it will immediately pass the information to the name node. And name node does not guarantee that it will going to process again the B1 C2 copy. It will start the another node. Okay. The moment it is going to pass the information, in the next second only, it does not guarantee that same node is going to process the B2 C1 also. Got it? Because B1 C1 is the input to the B2 C1, or let's say B1 C2 is the input to the B2 C2, or B1 C3 is the input to the B2 C3. Because each and every block is dependent to the another block. Because we have segregated this entire 200 MB into 2 blocks. One is B1 block, another one is B2 block. Again, this block has been segregated into 3 times. This also segregated into 3 times. Sorry, 3 times duplicated, both the block. Now, B1 block I have stored in these 3 nodes. Let's say these 3 nodes. B2, C2 I have stored in these 3 nodes. Let's say. So what happened? Once the B1 C1 And one block is completed, one copy is completed. It will pass the information to the master node. Then master node do not guarantee that the same node will going to process your data. So what happened? It will again you will going to the pass the instruction. Whichever node is active that point of time, it will pass that particular output to that particular node, and that particular output, based on that output, another B2 copy will going to start the processing. This is called distributed manner of processing. Distributed manner of processing, not parallel manner of processing. Got it? In Hadoop, we can process the data either distributedly or parallelly. Not both. We both cannot achieve using the MR. But parallelly, okay. How to process the parallelly? Not distributed environment. Okay. See here. I have stored the entire 200 MB of data. Let's say, and parallel style of processing. Let's say I have B1 enter. This file has been segregated into, let's say, small file. Okay, small file. Let's say I have designed my block size into, let's say, instead of 128 MB, okay, 256 MB. Block size is, let's say, it is 256 MB. You will get the 200 MB of data. There is no need to go for the divide this block. It will contain only how many blocks? Only one block. Only one block. And this block will be replicated 3 times. B1, C1, or let's say X, Y, Z. And this X copy will be stored here. Y copy will be stored here. Z copy will be stored here. Now you have another copy, another text file. Let's say another text file is, let's say, uh, b.log file. We have another file, b.log file. That is of 100 MB. For 100 MB also, no need to divide by the, because our, at this point of time, my block size is how much? 256 MB. 256 MB, if we will divide the 100 divided by 256 MB, how much MB it will become? It will generate only one block, right? Then again, it will replicate it into 3 times. 3 times. PQR. Let's say PQR. PQR. Then what happened? PQR also I can store in different nodes, right? Got it. There is no dependency with the one block to the another block. Because entire data I store in one node. One node. No. If this node goes down, I can start another node and I can process my data. Because here the file size is too small as compared to your replication size. Sorry, as compared to your block size. That is defined in the code-site.xml file, right? Got it. So in this way, what happened? We are going to process the data. There is no dependency with the a.txt file with the b.log file. No dependency. There is no dependent network. So what happened? I can process the data from this here, one node for the a.txt, another data for the b.log. In this way, what happened? I can perform the parallel model. At the same time, I'm going to process the data. So, Hadoop is super concerned with the processing style of, either you can achieve the distributed model of processing data, or you can able to process the data in a parallel manner, but not both. Got it? But Spark, how it will going to process your data in a parallel model? Let's see. We supposed to discuss these things in the architecture, but let's give you one hint only. That's all for your understanding. Here, what happened? Spark context. What is Spark context? I will let you know. Don't worry, because these are all interview questions, and I will explain in detail the architecture things. Okay. There is a cluster manager. Anyone is any doubt in this? How do we processing the distributed environment, distributed data? Try to understand here. This is one our worker node. Here, data node is known as the worker node. Okay, there is one term is there. Here, data node is known as the worker node. Node 1. Here, worker node 2. Now, executor 1, executor 2, executor 3. Here it will contain executor 1, executor 2, executor 3, executor 4. What happened? Okay. This is known as executor. Okay. Executor. This is Spark architecture. So I will explain in details later. Just to give you a small information about the how it will going to provide you the parallel style and distributed style of processing. Okay. So what happened? Whenever you are going to submit your Spark code, okay, this is known as a driver. Driver. Whenever you are going to submit your Spark code or the program, that program is ultimately submitted to the driver, and that is known as the driver program. Okay. Then what happened? It will active the Spark context. There is a main method within this and active the Spark context. This Spark context will initialize the session for you. Then it will talk with the cluster manager and tell that cluster manager, I need to process the amount of data. Okay, I need to process the job. Could you please let me know the available worker node? Within the cluster, so many worker nodes are there. Then cluster manager will talks with the cluster, and cluster manager is an intermediate person. We can say it is a broker. It will talks with the cluster, and whichever node will be free, those node information passed to this particular Spark context. Are you getting my point? Those node information means, okay, node 1 is free, node 2 is free, node 4, 5 is running. So what happened? It will pass the information that worker node, this node 1 is free and node 2 is free. And node 1 has 3 executors, node 2 has 4 executors. Along with their size, it will pass the information to the Spark context. The Spark context is what happened. It will divide the particular job into number of executors, because it come to know that there are total 7 executors are there. 7 executor means 7 person, 7 people. Got it? 7 person are there. Now he will divide the entire job into number of stages. And each stage define few tasks. Task 1, task 2, task 3. Got it? Stage 2. Again, it will divide few tasks. Stage 3. Again, it will divide into few tasks. And each of the task 1 is assigned to executor 1. Task 2 is assigned to executor 2. Task 3 is divided to executor 3. Now, in the stage 2, another task will be assigned to worker node to executor 1, worker node to executor 2, another task. So what happens? Each and every task, it will perform a small computation. It is an individual computation of the total job. Are you getting my point? It will compute the a small portion of interpretation computation of total job. So what happens? It will executor will automatically perform this task, and in the cache memory it will store the data. Every executor has their own cache memory, Okay, they will store the result of the task in the cache memory. And once executor 1, executor 2, executor 3, all are executing at the same time. Because suppose in a simple layman style, I am going to explain you. Suppose in my team, I have, let's say, 5 members. You will get a job to perform it. I'll divide the entire job into few stages means, okay, sprint, sprint 1, sprint 2, sprint 3. Within this sprint, let's I have to perform on the basis of priority. I have divided the into sprint, and within the sprint, this is the task I have divided. So entire task, let's say, out of 5 members, 3 members are free and 2 are occupied. So I cannot assign those tasks into these 2 members, right? Because they are already occupied with some work. I cannot assign those tasks to the total whole 5 members. But I have 3 member of there in the team. So what happened? I divide the sprint tasks into, I'll divide to one, team member 1 to one task, team member 2 to another task, team number 3 to another task. So what happened? It will perform individually, this will perform individually, this will perform individually. And then they will report to me. Got it? Are you getting my point? So what happened? It will, I am passing, I have already distributed the tasks. Then I am also processing the data performing the data in a parallel manner. Anyone is having doubt in this? How Spark has your Spark style of processing. Spark style of processing means it will provide you the distributed as well as the parallel style of processing. Are you getting my point or not able to understand? Means raise your voice, because definitely 150% they will ask you, what do you mean by distributed and parallel style of processing? You will say both are same, then they will tell you, they will ask you another question, how prove me how they are both are same. If not, then they will ask you why it is not. Okay.
Srinath,
Yeah.
can I ask a question?
Yeah. Sure.
Okay. So the dividing the job into stages, that is the work, like Spark context do that, isn't it? So Spark context will take care of dividing the job into stages, and then stages will be divided into number of
Correct.
tasks,
Correct.
right?
Yes.
And
Yes.
number of tasks has to be equal to the number of executor, isn't it?
Number of tasks will be the not equal to executor. It will check that whichever worker node is having a executor is free. Okay. Suppose here I am having 2 executor. I am getting 2 executor. Executor 3 is occupied. Then what's happening? From this node, these 2 executor will execute the task. It will take 2 tasks. From this, I have 3 executors free. This executor, let's say executor 4 is totally occupied. Then what happened? I'll process the task. Got it? Suppose, simple layman style I'm trying to make you explain. Just 1 second. You have to understand one. Here. Suppose you are here. Okay. Now you are the project lead. Okay. Let's say project lead. You are not going to manage a single account, let's say. Okay. Here what happened? Project lead means here you are the Spark context. So let's say a simple layman style I'm trying to make you explain. Okay. So you are getting some job in a particular account. Okay, account one. Let's say it is account one, account two, account three. Three projects are running, or let's say A1, A2, A3. Okay. Now, in account one, you have one manager. Okay. Sorry, I missed this point. Who is managing your data? Spark context. Spark context. Okay. In your team, what happened? In your team, you are getting a job. Job means there is you divide the entire job into entire tasks. So let's say job means you are planning to build a entire pipeline for a particular project. Okay, data pipeline line for let's say streaming data. The entire pipeline you cannot do in a single day, right? It will take some time. You need to understand the data. It will divide the data into let's say streaming. The first page you are planning to the page one, page two, page three. Okay. Bring the data into the your environment. The first thing you are planning to bring the data into your environment. Let's say it is a raw layer. Another from the source to raw. It is from source to let's say better. The first information here, first thing is to bring the data into source to raw. Next level of target is raw to stage. Next level of stage to curated. I'll tell you all this there later. Don't worry. At the project explanation, I'm technically term. I'm trying to make you understand few in a simple manner. So what happened? You are getting this job to make the design a data pipeline for the streaming data. First, what is your importance? You need to in the first sprint. This is my job. I will divide this job into number of stages. So data pipeline, I've divided into stage one, stage two, stage two, three. Got it? Are you getting my point? Now, to bring the data from the source system to the your raw system. Raw means your the environment, the landing area. Whenever you are going to first bring in into your environment. Until unless data is won't bring to your environment, you cannot do any processing, right? The same way, whenever you are going to deal with the hardware environment, first of all, bring the data into the HDFS, then we will start processing. Because our logic, we cannot push the logic to the their environment and run the code, right? It is not at all possible. First of all, bring the data to my area, then I will process it. That's what the thing is, right? Got it? So in similar manner, from the source system, I'm bringing the data into the raw. To do this, I divide the source to source, bring the data into the source system to the raw. First of all, I need to connect to the source with the first. What is the first step? One task is to perform connect. Connect it. Connect the source system with the raw layer. Means raw layer means your database environment or Hadoop environment or any environment, the environment that you are using for the particular pipeline. Got it? Or Snowflake. First connect the both the system. Let's say it is a Kafka system and raw is your database system. I am connecting both the environment. First task is to connect it. To connect it, what should I do? I need to write some API code or something else. Okay. One you have connected. Then after connecting the data, next task is to design a job Another thing is to another thing is to design a job for this one to run this particular API code. Okay, all these things I can do parallel, right? No dependency. One person I given the task to create a job to job means create a tag. Okay, then I need to ask one another person to create a tag. Okay, this one write the API code. Connect means API code. Write the API code. So suppose I have three people. Okay, let's say executor. Executor one. Then at that point of time, to divide the entire stage. Okay, this particular job has been divided into three stages: source to raw to stage to curated. To bring the data source to raw, I gave some tasks. I've divided into number of tasks one, task two, task three. Got it? Then this stage, then again stage two. Stage two is also likewise the same. I asked one person to design the API. I asked one person to create a job. I asked one person to prepare the tag. All these tasks is no at all dependent at all. Once you design, then you need to start the integration and testing. Then deploy it. Got it? Stage two. It is stage one for this one. Then stage two will be, what is the stage two for this one? Source to raw. Source to raw. Next, test it. Next one. Then deploy it. Then post documentation. Stage two, entire job. I've divided into stage one, stage two. Forget about this raw to at this point of time. I'm taking this particular source to raw. Source to raw, I have created created three tasks. Stage one created three tasks. Okay. Stage one content, write the API code to connect source to raw. Then design the job. Then prepare the deck. Then test it, build it, then deploy it, build and deploy, then post documentation. So all these tasks I can perform parallelly by using the different nodes. Are you getting my point? So this is how the Spark engine will work in the same manner. More layman example. Suppose you are going to prepare a house for you. You have given to one broker. Okay. Let's say this broker is saying that I cannot build the entire house in one day, sir. I need to phase wise, I need to work it. Because I have how many workers are there? Let's say under me, one person is there who is taking care, let's say, one person is there who is taking care of the material supply. Another person is there who is do the planning. And another person is there who is do the designing or core level building. Got it? So this three person is, so what happened? Broker is your cluster manager. You are the broker is your cluster manager. This person is your broker. Okay. To build the house is given the charge to the broker. Broker will have again three people. One is who is responsible to supply the raw materials. Another person is to plan for the house. Another person is to build. Again, each person has their own number of tasks. Okay. They have executor, wherever executor. This is worker node 1, worker node 2, worker node 3, worker node 1, worker node 2, worker node 3. Every worker node has, let's say this raw, it will actually use for the raw materials, supply the raw materials. This person has, let's say, 5 people are there. 5 people means 5 executors. This person has, let's say, 4 people are there. 4 people means 4 workers. This person has, let's say, 15 people. Got it? Are you getting my point? I've tried. Are you able to understand or not able to understand? So what happened? It does not guarantee that all the 5 members are there who are supplying in the raw materials. They are all are free. Out of these, 3 people are free. Let's say in designing phase, only plan and design. There only 2 people are free. In build phase, it will let's say it is 10 people are free. What happened? Means those who are free, you can they will assign the tax to them, right? Got it? They will assign the tax to those people, those who are free. So what happened? The entire tax, the broker will divide. Okay, first of all, let's concentrate on the supplement of the raw materials. The raw materials contain different things. Right? Got it? Are you getting my point? How the tax has been assigned? You have given the tax. You are the leader. You are the spark context. You are the driver. Okay, you are given the tax to the broker. Broker see that. Okay, one supplier is there who is supplying the raw material. Another supplier is there who is give me the architecture or plan. Another supplier is there who is build the core construction. Under this, there executor means these are the 5 labor, 4 labor, 15 people labor. Each labor will perform. There are 3 labor are free. Here 2% are free. Here 10% are free. These are the executor. Now what happened? The broker will, okay, we cannot go at the same time I'm going to supply, at the same time I'm going to plan, at the same time I'm going to build. I can't do anything, right? So instead of dividing the entire house plan, building the house plan, it will going to divide the first. First of all, let's have the plan first. Okay. Then what happened? The plan, whenever come to the plan, let's concentrate in the plan first. In the plan page, what happened? This plan manager, this manager will told the broker, I have 2 people are free in my hand, and I will send you one plan is 2. It will divide the plan into number of tasks. Got it? Number of tasks. Because entire job is divided by the broker into number of which one? Number of stages. Now stages into stages given to stages 1 given to the, let's say, plan. Stages given to the stage 2 given to the raw material supplement. Stage 3 given to the build the house. Now stage 1 is to plan. So stage 1 is again contains so many, let's say, tasks. Task 1 is to, it will send one person to the personally to the area where you are going to build the house. It will see the how many square feet are there, and it will take the measurement of the entire land and how many square feet are there. All these things it will take measurement in and gives to the plan manager. Then another person document those things and design it properly in a pictorial manner and send to the plan manager. Okay, this is the design as per the square feet. In north direction, this block will be there. In south direction, this block will be there. There is the kitchen, there will be the hall. All these things they will plan and gives to the plan manager. So stage manager, these things will be performed individually. Next one, plan, here 2 people will, 1 people will perform the duty, 1 people will, again the based on the square feet, you can design the plan. At the same time, and both the executor will execute it at the same time. Got it? And at the same time, I can also execute this one also, this stage also, raw material. Okay, I require in a estimated, this is the 2 crores of estimation, under 2 crores estimation, this is the a rough estimation is this one. Please send me the immediate material. This is also executed fine, right? At the same time. Got it? Are you getting my point? I can perform divide the entire job into number of tasks. Stage 1, stage 2, stage 3 into different phases. In phase 1, I do perform task 1, task 2, task 3. Phase 2, I am going to perform the task 3, task 4, task 5, task 6. Right. And this is how what happens. Spark will process your data in a not only distributed manner, but also parallel manner. Okay. Are you getting any question, anything else? Still the discussion are there. For this one, no, don't worry, because I'm going to cover the Spark architecture. Okay. Any doubt, anything else? Hello? Please talk to me. You are not able to talk, then I cannot able to understand whether you are able to understand or not able to understand.
Hello. So
Yeah.
If maybe yeah, I'm asking the future question. Maybe you'll cover later on. But yeah, you can say that okay, if you're going to cover later on. So how do we decide like how much driver memory we need, how much
That
like
is
how much?
another level of discussion, Durgesh. So those things I will discuss in details. Whenever
Okay.
you are doing, I am going to talk about the case and persist. Okay, how it will
Okay.
going to discuss because that is an interview question.
Okay.
Suppose earlier what happened, earlier case whenever you are dealing with the Hadoop, right,
Mm.
we cannot able to understand how much data we are going to get. But these days what happens since we are using the everything executing in the right in database environment, there is a auto scale feature is there. No need to take care of headache. No need to suppose we are getting, let's say we are getting, we are 5 GB every, we are getting let's say 5 GB of data. This week another week we are getting let's say 5 GB since for the last let's say 7 months. But all of a sudden the data size is increase, we are getting 10 GB. Another let's say one another week we are getting 12 GB, or another week we are getting let's say 20 GB, like that. In an incremental way we are getting the data. To deal with such a situation, what happened in the Hadoop era, we can say Hadoop era, that point of time, we need to manually, manually, we need to define our executors. Means the executor memory, driver memory, all these things we need to define. But these days, what happened? Since the database has been comes into picture, database will gives you one feature like auto scaling, and or because of the same what happened, whatever may be the data size, right? It will ultimately what happen? It will process this many of data by doing the calculation. First of all, it will calculate what is the volume of data we are processing. Based on that, it will allocate the number of. It will automatically increase the size of the executor memory, driver memory. All these things automatically it will going to. No need to take care. No need to interfere. But earlier, what happened? Earlier, we need to define. We need to just predict. Okay, another one. Oh, this is the situation. So let's say this is the month of let's say end of the quarter, and supposed we are getting the so much data. This is the let's say prediction. Then what happened? I need to design my executor in that level. I need to increase the size. Got it? So those things, and also there is a dynamically also done. How dynamically done? That is I will discuss later. Okay, got it.
Okay, Jagannath.
So the thing is simple as you will just the house plan, right? In the same way, suppose I have 100 of workers are there. Okay, you require one house to build. Okay, I'm sending you 10. No, tomorrow you require so many things to work on. Then okay, tomorrow you just give me a call. I will send you 100 workers. Sorry, 50 workers or 40 workers. Auto scaling is working in that way. In that way, got it? Based on the, it will evaluate the entire volume of data, then divide the entire job into number of stages and tasks, then automatically it will increase the size of the executor memory and your driver memory, all these things. Okay. So futures is there. So we'll keep on continuing in the distributed computing. This is another future, but still the discussion are there for the distributed computing. Okay.
Okay, just one more thing, Devnath. So straight away we can say that MR is doing the distributed processing and Spark does the parallel processing, right?
No, MR, by using MR, we can achieve either distributed or parallel processing, but not both at the same time. Got it? But by using Spark, we can process data both in a distributed as well as parallel manner at the same time. Are you getting my point? This is a difference. And that's the reason what Spark is faster. Because whenever you're simple point, just to understand it. In a layman style, I'm just to makes you understand these things, right? So just okay. Annotation is not coming. Hmm. Suppose you are getting one job. Your job divided into number sprint one. Sprint one means stage one. Sprint two. Sprint three. Got it? Are you getting my point? Then this sprint you are divided again to task one, T2, let's say T3, T4, like that. Same like let's say T5, T6, T7, T8, T9, T10, T7, T8, let's say T9. Okay. So what happened? Task 1 will be assigned to one executor. Task 2 will be one executor. Task 3 will be one executor. Task 4 will be. At the same time, what happened? I divide the entire task, entire stage, means one sprint task, one sprint job, one sprint means one stage, first phase of the job. The job I have divided into phase 1, phase 2, phase 3. In the phase 1, what happened? I divide in the phase 1, this is my entire task, entire job that you can say I need to perform. Then what happened? Task 1 I am going to gives one member, task 2 another, task 3 one member, task 4 one member. In this way, in a parallel way, I have divided the phase 1 things to different member, sprint 1 task to different member, and parallelly I can complete all the tasks for that particular sprint. Are you getting my point? This is how your Spark will do. Are you getting my point or not able to understand? Still you have doubt.
No, they're not good.
Okay, good. So this is how we are going to deal with this particular distributed and parallel processing. We are distributed and do the parallel processing. That's all, which is not at all possible in Hadoop. And that's the reason what happened. Hadoop is very slow. Again, MR is what happened. One more drawback is MR is every time going to read the data from the hard disk, not from the memory. But all these tasks will be going to executed by the executor, and every executor they have their own cache memory, and cache memory is much more faster than your simple RAM, right? Got it. That's the reason what happened. Task 1, task 2, task 3, task 4. All these tasks are executed in faster manner. We'll come to know more details about the Spark architecture in upcoming session. Okay, because after completing the Spark architecture, so many theory are there. Because I need to complete everything in details. Whatever I'm going to provide you, that is the most solid note, and that is enough for you to crack the interview, to survive in the industry, to do anything. I'm going to give you n number of example. Don't worry, from the example point of view, you need to practice it. You need to showcase your standard. Okay, definitely you will say that at the end of the course, whatever I'm going to give you, that will help you a lot throughout your career, especially into the PySpark. Okay, Python and PySpark, no worries. Got it? So,
Yes.
okay, fine. So let's wind up the session here. Again, in the evening, we will connect. We'll discuss more things about this particular key features, and all these notes I'm going to share with you. Okay. And this time, I'm not going to give you in a Word document. I'm going to give you in this manner. And uh, why I'm going to give you in this manner? Because it will help you. Suppose you are going to tomorrow, you are going to attend some interview. Okay, it will becomes easy for you to okay. This is the content. This is the content. Okay, you have to look around before attending the interview. Half an hour before, you just go through the theory and attend the interview. Okay. Are you able to understand or not able to understand? Please clarify me, because these are very, very important, because most of the people in the Spark, especially, see, in the PySpark or Spark, they will ask you minimum 60% concept they will ask you, including the your practical scenario. Sorry, practical scenario will 40%, hardly 40%, not more than that. Either they will ask you one or two practical, not more than that. But theory definitely they will ask you. So many things. What is salting technology? What is vectorization? What is page rank? What is stateful transformation? And what is Spark context? What is Spark session? What is GLOM? What is the map, flat map? Okay. What is map partition? Map partition with index. So, so many questions are there. All these things are the theoretical question. Okay. We cannot neglect it, because every interviewer will ask those things. If you speak, if you read minimum 3 to 4 times, you can able to understand. Okay. And more importantly, I am not going to use this bookish language here, and try to the way you need to represent in the interview in the same manner I am trying to write here the note. Okay. So that you are feeling like you are just talking with a person. You are speaking with a person. Okay. Got it. Because the explanation is more important. So, okay, let me stop the session and I will share something. That's the reason. Let me stop here. It's not good to stop the recording here. Stop. What happened?